It's often the case that MapReduce code is written in Java. However, to make things a little easier for us, we've actually written our mapper and reducer in Python instead. And we can do that thanks to a feature called Hadoop streaming, which allows you to write your code in pretty much any language you'd like. So first of all, let's double check that we have our input data in HDFS. So if I Hadoop fs-ls, then there's my input directory. And if I look at that directory, then yes, there's purchases.txt in there. And in my local directory, I have mapper.py and reducer.py. That's the code for the mapper and reducer written in Python. We'll look at the actual code in the next lesson. Okay, to submit the job, we have to give this rather cumbersome command. We say Hadoop jar, a path to a jar, then I specify the mapper, I specify the reducer, I need to say -file for both the mapper and the reducer code, I specify the input directory in HDFS, and I specify the output directory to which the reducers will write their output data. And we're calling that job output. I hit enter, and off we go. Hadoop's pretty verbose, as you can see. As the job runs, you'll see a bunch of output which shows us how far along the job is. It turns out that for this job, Hadoop will be running 4 mappers, and our virtual machine here can only run 2 at a time, so the job is going to take longer than it would on a larger cluster. Actually, that's worth mentioning here. With the size of the data we have for this example, which is only 200 megs, realistically, we could probably have solved this problem faster by just importing the data into a relational database and querying it from there. And that's often the case when we're developing and testing code. Because the test datasets are pretty small, Hadoop isn't necessarily the optimal tool for the job. But when we're done testing and we need to process our full production data, that's when Hadoop really comes into its own. So, as you can see, the job is now nearly complete. And when the job has finished, we'll get a set more output, and you'll see that the last line tells me that the output directory is called job output. Let's take a look at what we've got in there. Hadoop fs-ls shows me that yes, I now have a job output directory. And if we look at the job output directory, you'll see that it contains 3 things. It contains a file called _success, which just tells me that the job has successfully completed. It contains a directory called _logs, which contains some log information about what happened during the job's run. And then it contains a file called part-00000. That file is the output from the one reducer that we had for this job. Let's take a look at that by saying Hadoop fs-cat part-00000, and we'll pipe that to less on our local machine. That's the contents of that file, which is the output from our reducer. It's the sum total sales broken down by store, exactly as we wanted. Incidentally, if you want to retrieve data from HDFS and put it onto your local disk, you can do that with Hadoop fs-get. Hadoop fs-get is the opposite of Hadoop fs-put. It just pulls data from HDFS and puts it on the local disk. So as you can see, now I have my local file.txt on my local disk, and I can manipulate that however I'd like.